We can also use tables to find the equation of any function from a couple of points. Let's take a look at a couple of examples over here. Let's say we wanted to find the equation of the line of best fit for this scatter plot. So we can start by just inputting the points into a table. Again, you hit this plus sign and it's table. Then we start throwing in some points. So this looks like we have 2, comma, let's call that about 6. So we'll type in 2 over here and 6 over here for the y value. And we have 4, let's call that about 14. So we go back, this is 4, and this is 14. And we could do 6, let's call that 18. So now we use what's called a regression to find the equation of this line from the points. So notice that our coordinates over here are x sub 1 and y sub 1. So what we want to do here is y, and then we can create a subscript by using the underscore button. So that's y sub 1. Then we use what's called a tilde over here, and make sure you're out of the subscript. The tilde is usually created by holding shift and hitting that top left button. It looks like a little squiggle. Basically means approximation. And then again, these are all in the linear equation mx plus b, right? So that's m, and then we want x, and again, remember, it's x subscript 1 plus b. And you can see how it gives us the parameters m equals 3 and b equals 0.666. So m, our slope, should be about 3. Our y-intercept, b, should be about 0.666. And we see that the closest fit over here is a. In fact, the slope is exactly 3, and then the y-intercept 0.666 is closest to 0.8. Now, we don't even need a chart. We don't need a scatter plot, right? We could do this directly from 2 points if we wanted. If we wanted the equation of a line that contained the point 1, 3, and 5, 15. So let's just get rid of the bottom point here, and we can make this 1, 3, and that is 5, 15. And you could see the m, our slope, is 3. The b, the y-intercept, is 0. That would be 3x plus 0, or in other words, just 3x, which is a. And again, we could work directly from a table. Makes it a lot easier to just copy directly, right? So we have the 0.1 and 136. And then we have the other points over there, 3, 132. And that honestly is enough on its own, right? 2 points is enough to find the equation of a line, but if we wanted to toss this other one in here, 5, and this was 128. And you can see the parameters over here end up being -2 for our slope, 138 for our y-intercept. And that aligns with C, right? -2 for the slope, 138 for the y-intercept. Now we can use regression on more than just lines. Let's say we have a quadratic function over here. So we'll pick a couple of points to throw into this function. The first was the y-intercept, which is at 0, 12. That's this point over here. And then we have 1, 7, and 2, 3. So we'll type in 1, 7, and 2. So we'll make that 3. And then we could go on from there. Let's just throw in the minimum point there, 4, 1, and then 5, 2, and 6, 4. So 4, 1, 5, 5, 2, and then that last point we found was 6, 4. So again, we use our regression, y subscript 1, and then tilde. Now, this is in the form of a parabola, so that's going to be ax sub 1, and that's going to be squared. So we square that. Nope, we got to square this whole thing. So we square that, and then we do plus, and then that's going to be b, and then x sub 1 plus c. And notice how it creates this parabola for us that kind of just goes along those points. So the A term is about 0.744, the B term is negative 5.75, and the C term is 11.9. So now we just got to figure out what matches that the best. And we can see all the A terms are about 0.9. We can see all the B terms are about negative 6.5. But the C term should be 11.9 or so. And that is closest to 12.5, which is answer choice A over here.